This is Unit 10.1, Weather and Climate. We're going to do a little recap on what weather is. Right? It is the short-term period of time that tells us about how things are during hour to hour, day to day, month to month, or even year to year. There are many factors that go into determining the weather, and you can see that list over here on the right-hand side: temperature, precipitation, cloud cover, wind, humidity, and a dew point temperature, which we're going to go into these during this unit. So why does weather change? It changes due to the motion of Earth. So we have two vocabulary words here that are necessary and important for you to know the difference between. They sound very similar, but they have different meanings and how this impacts our weather. So the first one we have is rotates. Okay, our Earth rotates on its axis. This means that it's moving from west to east, and this is what's creating day and night. Then we have revolves. Okay, so our Earth revolves around the sun. One complete revolution is 1 year. Okay, so the rotating on its axis is that first picture. So it's got the axis and it's rotating on it. And then we also have it revolving around the sun that is in the middle. All right, so that it is doing both things at the same time.
All right, so if we take a look and we think about the fact that the Earth is kind of doing like an ice skater dance, right? It is spinning around on its own ice skate while going in a big loop around the rink. We have to think about why we end up with these different types of weather, these different temperatures that we have, all right? And the next question we think about is, why don't we have the same kind of weather everywhere? And that has to do with that tilt. It has to do with that axis that the Earth is on. And it has to do with the angle at which sunlight is hitting different parts of the world. So there are two different ways in which sunlight can be hitting different areas, different countries, different continents on our planet. The first is through direct sunlight or high intensity. Okay, if I am getting hit with direct sunlight, so if that line is pretty close to straight, that's going to result in warmer temperatures. All right. And the most direct sunlight location on our planet is the equator, right? Right around the center of the Earth, that middle portion. And our analogy here for you is being in the spotlight, right? So imagine you're on stage, the whole room is dark, and they turn on that one spotlight, and it hits just you. It's not illuminating the whole room. It's not filling the whole room with light. It's just focusing on light on you. And you're going to feel that light. You're going to feel that heat because it is just directed on you. It's covering a small space and it's hitting you directly. And that's exactly what happens when the different parts of the world, different times of the year, are getting that direct or high intensity sunlight. And you can see that pictured here at the bottom on the left, where we see these kind of direct perpendicular angles of sunlight. And we can see the kind of land we would be at, right? Beaches, sunny, tropical weather. That's what we'd be thinking about if we were near the equator. The other type of sunlight we could have is indirect. And there's obviously many different levels, different angles of indirect sunlight. And that's going to result in less intensity, all right? And thus cooler temperatures, all right? So we're not going to have that hot, sweltering equatorial weather. And we are going to have a wide range of temperatures, getting cooler and cooler as we get closer and closer to the poles, right? The North and South Pole. On either end of our planet. And the closer we get to those poles, the more indirect or the more angled that sunlight will be. Usually we talk about examples that have to do with like putting peanut butter on a sandwich or maybe sprinkling spices on, some chicken or steak that you're making. If you were to put all the spice or all the peanut butter in one spot and you were to take a bite of that sandwich, if you didn't bite in that one spot, you're not going to taste any of the peanut butter or any of the spice. All right. But if you spread the peanut butter and you spread the spices across, you're going to have different levels of peanut butter and spice across that same thing. Don't put both on the same. That's mixing analogies and dangerous. But if we do that spreading, then you're going to have more right where you put it on, and you'll have less as you spread it across. And that's what you can see in the two pictures on the bottom going towards the right, you can see about what's called mid-latitude, or about halfway between the equator and the North or South Pole. You can see the kind of 45-degree angle, that intensity level has dropped, and that light or that heat is going to be spread out over a larger area. And then you could see what it would look like at the poles, all right? A much sharper, more acute angle, and obviously much, much cooler temperatures because the sunlight has been spread out over a much, much larger space. So if we have this variety of intensity of sunlight and we have this variety of temperatures, well, the next question that usually gets asked is, well, okay, well, why do we have seasons, right? Winter, spring, summer, fall. I know obviously in Chicago, we tend to, or the Chicagoland area, we tend to say we don't really have all four of those seasons. We tend to have winter and summer, right? Our fall and our spring kind of get lost in there sometimes. But we do actually have all four seasons around the world, and they vary slightly in terms of their criteria and what happens. But we have these seasons for two reasons, all right? And please note them, highlight, bold, etc. in your notes. The two reasons for the seasons are, one, the Earth revolves around the sun, all right? So the fact that the Earth is going around in what's called an elliptical orbit, so it makes this big, giant, almost circle around the sun, that's one reason. So different parts of the Earth are going to have direct or indirect sunlight at different parts of the year. All right, so that's our first reason. And the second is that Earth, all right, our planet, as you can see pictured on the top on the right, is on a fixed tilt. Okay, its axis is on a fixed tilt. It's not a perfect circle that sits upright. It's on a tilt. And because the Earth is angled as it rotates, it means, as you can see with these arrows, that direct and indirect sunlight are going to hit different hemispheres, the north and the south, differently throughout the year. Okay, so I'm going to jump out of this really quick, and I'm going to pull up a really important video that is linked, and I'll show you where that video is linked on your slides here. But you can see in terms of that direct versus indirect sunlight here, the MIT students give a good example of that, and they're showing it with a flashlight, right? So if I just shine that flashlight kind of in that spotlight mentality, that's going to be my direct sunlight, and it's going to hit that spot pretty significantly, okay? They're going to draw a little arrow. That's our direct sunlight parts of the world. And then look at what's happened when we put that flashlight on an angle, right? Much like the sunlight would be hitting on an angle because our Earth is on a tilt, right? And so we can see that if that flashlight is hitting on an angle, look at what happens to the light. It no longer is centered like a spotlight, but that light gets spread out over a larger space. And notice, I'll jump this back really quick. Notice the difference in intensity. Much brighter when we're focused in one area. And then, she's already drawing. A little bit dimmer as we spread over a larger space. And that's much the same that happens with solar radiation and the sun's light as it hits our planet on these angles. So for about half of our year, the northern hemisphere is going to be tilted towards the sun, getting more direct sunlight, warmer temperatures, spring and summer. And then for the other half of the year, the northern hemisphere is going to be tilted away from the sun as it revolves. And so that's going to give us more indirect sunlight, resulting in cooler temperatures, fall and winter, right? And here is that video. We will be asking you to take a look at that on your own time, as well as when you are watching this lecture.
When do seasons change? These are our seasons changing for the Northern Hemisphere. Remember, just like Ms. Laporte said, it's going to be different when you're taking a look at the Southern Hemisphere. So Northern Hemisphere, we have an equinox and we have the solstices. The equinox are 12 hours of day and 12 hours of night. This is the vernal or the spring equinox, which happens this year on March 20th, 2021. And the autumnal is in September 22nd. And we also have the solstices. This is the sun is at the most northern or the most southern point. So this means that the longest day for summer is on June 20th this year, and the shortest day for winter is December 21st. And then we also have a diagram here just to kind of show you how that looks and what that looks like for our Earth as it is going around the sun, and where these equinox and solstices, kind of where they take place, what they look like when they are going around.
And just note the fixed tilt. Notice that this angle, see this stick? There's not really a stick, but see that stick indicating the axis of the Earth, that it's rotating around. Notice that it stays on the same angle at all points when it revolves around the sun. That's what we mean by fixed tilt. And that's why for half of the year, this northern hemisphere is going to tilt away, and for half of the year, the northern hemisphere is going to be tilted towards the sun. And obviously the opposite would be true for the southern hemisphere. That's why we have opposite seasons from the southern hemisphere. So this is a good diagram, as well as your reasons for the seasons activity, to help you understand those concepts.
All right, so other elements of weather, one of those being precipitation. So precipitation is formed in clouds, such as rain, freezing rain, sleet, snow, and hail. These different types of precipitation are based on the air temperature at the various layers of our atmosphere. All right, and then also clouds. Obviously, clouds are important for us. So clusters of water and ice crystals are formed and condensation in the clouds. Okay, it warms that warm air rises, and then it also cools. The height and the forms of those clouds tell us what type of weather we're going to be seeing and having. So we'll have, I'm sure have heard about all these different types of clouds back in elementary school, like cumulus, cirrus, stratus, and cumulonimbus.
All right, some other elements that are important and impactful for weather. The next one we're looking at is wind. So wind is obviously movement of air, right? Especially in the wintertime, we really feel that in kind of a cold, nasty way, especially as of late. And there are two different factors, again, that kind of impact our wind. The first is that our Earth gets unevenly heated. All right, we've spent some time talking about direct versus indirect sunlight, right? So different parts of the Earth are getting more intense solar radiation, so higher temperatures, then other parts of our Earth are getting cooler ones. And if you live in a house that's 2 stories, or maybe have a basement, you kind of know how hot and cold air works, right? Hot air rises, cold air sinks. So it tends to be cooler in basements, and it tends to be hotter up in those 2nd or 3rd floors or those attics and things like that. Same thing happens on our planet, all right? So what happens is the cooler air that is near the poles is going to sink towards the equator, and the warmer air that is heated at the equator, getting the most direct sunlight, is going to rise and go to closer to the poles. So you end up having this kind of cyclical movement of air. I think I put the analogy here, thinking of like a lava lamp, right? We have those big bubbles of lava kind of moving around. We call them convection currents. Big words. But basically all that means is we have this kind of cyclical movement of that sinking and rising based on the temperatures. And that creates these global wind cells that result in a lot of the different types of movement of temperature and movement of different fronts, which we'll learn about later on throughout our planet. The second piece that impacts weather is the rotation of the Earth again. So the Earth is spinning around, all right? It's spinning on that axis. And what that does is it causes the wind to bend, all right? So if you've ever flown on an airplane, you may have watched, the little video that it shows you when you're flying somewhere, and it shows you the route to get somewhere, all right? And you would suspect that if you wanted to end up straight ahead from somewhere, you would just go straight. But because the Earth is a spinning object, all right, you'll notice here my paper airplane ended up all the way over on the right-hand side there. And that's due to something called the Coriolis effect, all right? The bending of the pathway of an object based on the fact that we are on a spinning object, the Earth. And you can see that the Coriolis effect works not only in the northern hemisphere, but also, as you saw there, in the southern hemisphere, just in the opposite direction there as well. Okay, so this is obviously really important, these wind patterns, not only for plane, travel, so air travel, when we get to travel again a lot. We can't wait for that. but also for things like these buzzwords that you hear in the news, things like polar vortex or El Nino or La Nina. Polar vortexes, obviously, it's a popular term to hear about on the news or in the media now. Polar vortexes have been around for always. Basically, what a polar vortex is has to do with a lot of cold air in a huge area of what's called low pressure that sits around the poles. And so you can see here, this is the North Pole polar vortex, which is the one that impacts us and has been for the last several weeks. And what happens to vortexes in the wintertime, because we are receiving less intense sunlight during this time in our hemisphere, is this polar vortex expands and it starts to drop down, all right, or further south. And as it does that, it tends to make the temperatures really cold, especially in Canada and in the northern United States. But sometimes the winds, called the jet streams, the really fast winds, they tend to get kind of bendy as well. And when they get a little more bendy than they should, that polar vortex sinks into those empty spots and drops down into places like where we live, and even further down, like we're seeing these past couple of weeks in Texas and in other parts of the South, and even on the West Coast as well. Snow and ice and cold in places that normally doesn't experience that. You also have another phenomenon that relates to wind called El Nino, or the Southern Oscillation, sometimes La Nina, depending on the season. And basically, these are two phenomenons, two global climate pattern changes that have to do with a warmer and a cooler phase. And basically what happens when these two weather events occur is that the normal wind patterns in the Pacific Ocean reverse themselves. And so that sends everything kind of in a topsy-turvy, upside-down way, and doesn't only impact the weather in the Pacific, it also has global implications for other areas of the world, because we essentially have kind of reversed the flow of traffic in terms of the wind. And that can move different temperatures to different parts of the world that don't normally experience those. So you see higher increases of hurricanes, or you see lower increases of rainfall or things like that. Last but not least, in terms of our elements that impact weather, is something called humidity and dew point. All right, so when you look at your weather app, you're going to see two things that are talked about. And especially living where we live, we often talk about humidity in the summertime because it can tend to get pretty humid around where we live. And there are two ways to measure that, or to read humidity. The first is through something called relative humidity. And relative humidity is kind of like a percentage, all right, kind of like a grade. And it tells you how much water vapor the air has in it currently. So kind of like what grade you scored on an assignment. And we take that and divide it by the total amount of water vapor that the air could hold at that temperature. Kind of like the total amount of points you could have earned on an assignment, right? And we take that and we divide them and we multiply it by 100, and it gives us a percent. And basically the principle behind relative humidity says that the warmer the temperature, the more water vapor we can fit. All right. So obviously at higher temperatures, you have the capability of fitting more water vapor in it. And so it can tend to feel sticky. It can tend to feel humid because we can store more water vapor in the air. But it's not really the best way to talk about humidity, because when we look at percents at different temperature can kind of be misleading. And I'll show you an image of that in a minute. So what we tend to use instead, to be more accurate about humidity, is something called dew point, or the dew point temperature. And basically, this is the temperature for any given temperature where that amount of air can no longer hold any more water vapor. And it's when we start to see frost or dew show up on our plants or on our grass. And so this is a much better method to determine and identify humidity. All right, so taking a look here, just going to throw this on the big screen. And we can see here three different containers. All right, this is our analogy for relative humidity and dew point. If we look at each of these containers, you would say each container is about 50% full, right? It's got half of the container is filled with, in this case, water. But if we take a look, the relative humidity of each of these containers would say 50%. Right? 50% humidity. But if I look at the temperature, it is 55 degrees 75 degrees, and 95 degrees, that 50% is not the same amount of water if I actually measured it in liters or milliliters, okay? So when I talk about relative humidity, if I said it was 50% humidity on a day when the temperature was only 55 degrees, that's not that much. It's going to feel pretty dry. But if I said we have 50% humidity on a day when it's 95 degrees, look at all that water. That's a lot, all right? That is going to feel pretty darn sticky. So relative humidity, that percentage doesn't really help us out. By looking at the dew point temperature, by paying attention to what that dew point temperature says on your weather app, that's going to be a much better indicator. We'll take a look at that here. A much better indicator of what the humidity would be. So here is listed just some general categories of dew point temperatures. So pretty much anything under 60, 61 is usually going to be considered pretty dry and pretty comfortable. As we go over 60 in terms of dew point temperature, then we're going to start to get into that humid range. So this is a much better gauge for humidity than if we were to take a look at that relative humidity percentage.